All right, folks, today we are looking at operations with rational expressions. Rational implying that it's going to look sort of like a fraction, usually, always, okay? When we look at rational expressions, this first one starts off and says, state the domain and then simplify the expression. One thing we always have to be aware of on rational expressions is to never allow your denominator to end up equaling 0, because that would be undefined. When it says state the domain, that's what they're concerned about, is what kind of issues will you have with x so that your denominator doesn't end up equaling 0. Before you can determine that domain, you need to do factoring of anything that will factor. When you look at this first expression, the numerator does have a GCF that can come out. Let's go ahead and factor out that GCF. And the the denominator looks like a pretty messy function. Let's see what we can come up with for factors for it. As messy as it is, that leading coefficient is prime. It's going to have to be a 7x and a 1x. And then you look at factors of 24, and we all have our own way of factoring. I do just a guess and check because I don't want to take up a whole bunch of space doing special types of factoring. I'm just going to look at this and come up with factors of 24 that I can put here and here to make my outer and my inner get me a negative 46. Because it's positive, my signs are going to be the same. They're both going to be minuses. I'll go ahead and slip that in there. Which means that my outer and my inner are going to have to add up to a 46. If I look at that, probably I need to get this up kind of big. So how about a 6 here? 6 and 4. Would that work? Then you have a negative 42 and a negative 4, which gets you negative 46. We've got it factored. Hey, and you notice also that these are identical, which is going to be nice for simplifying. And we can actually use that. That would have been a smart thing to look at to give me some ideas of what these factors might be. Not that it has to work that way, but if I'm looking for something to simplify, then I need those to be identical. Before I do that, though, let's do the state the domain. Once everything is factored, that's when you can identify what values of x will make your denominator 0. Anything here, anything that would make this quantity 0, or anything that would make this quantity 0, would create a denominator of 0. That makes those restrictions to the domain. Up here I'm going to just state my domain. Typically, we'll just write x cannot be anything that will make the denominator 0. In this case, if I set that equal to 0, I'd have x equal to 4/7, which means I do not want x to be 4/7. And in that second quantity, I would not want x to be 6. Those are the restrictions on the domain right there. For later on, when we start solving, we will look at those restrictions to make sure that our answers don't conflict with that. The second part of this problem says to simplify it. Well, after it's factored, that's when you look to try to cross things off. And anything that's being multiplied can be reduced. We are multiplying right here, and we're multiplying right here. So that makes the 2 its own thing, and the x minus 6 its own thing. Makes this 7x minus 4 its own thing, and the x minus 6 the own thing. I'm just going to cancel those out, and I'm left with a 2 over 7x minus 4. I do not get to reduce this 2 and this 4. This 4 is caught up in subtraction with the 7x. Final answer right here. Let's try some multiplying and dividing. This first one I threw kind of a weird one at you. I did that on purpose, just so that you get something strange now rather than not just on your homework. This second quantity here, this business right here, that really needs to be written over 1. As we solve this, we'll think of it as an over 1. And this is like a big multiplication dot right here between them. If you're going to multiply, it's very similar to what we did on the simplifying. You want to factor everything first, and then reduce anything as long as you have one thing on top and one thing on bottom that can reduce. Let's do some factoring. This first one Factors of 15, that's going to just be a 5 and a 3. They're both addition. In the denominator, I could pull out an 8 on that, and then I'd have an 8 minus 7k times, over here I have a 7k minus 8 over 1. Now when you look at trying to reduce something, this looks very similar to this, and yet it's not quite identical. The 8 here is positive, whereas here it's negative. The 7k is negative, here it's positive. The signs are wrong here. Well, I can tweak this. Instead of factoring out an 8, I'm going to factor out a negative 8, which is going to keep this 8 negative and this 7k positive, and now those two quantities are the same, and I can reduce those. Other than that, I think that's all there is for reducing. I'm left with a k plus 3, k plus 5, all over negative 8. Let's look at this second one. This one is division. Very similar. No factoring in that numerator. 10 stays put, but instead of division, remember that we multiply by the reciprocal. I'm going to go ahead and factor this denominator, but I'm going to put it in my numerator. I'm going to factor out a 20, and I'm left with x plus 3. And then I'm going to factor this numerator, but I'm going to put it in the denominator. Looks like I can factor out a 2, and then I'll have an x squared minus 5x minus 24, which could actually factor more. I'm going to just squeeze in another factoring step here. It's going to be x and x. Factors of 24 that have a difference of 5. It'd be a minus 8 and a plus 3. So I'm going to cross that off, and this is my actual factorization. Now that I'm multiplying, I'm looking to reduce anything that I can. Looks like I have an x plus 3 and an x plus 3. And I have this 20 and this 10. Those could reduce. And that 2 could reduce. I think I'm done there. Let's see what I've got. X minus 2 and everything else canceled. In the denominator I have an x minus 8. Those are tied together with that subtraction. They're their own thing, so don't try to do any extra reducing with the x's or the 2 and 8. You're done right there. Let's look at some complex fractions. Complex fractions mean that you got fractions caught up inside of other fractions. And really, we just look at this fraction bar right here as a big old division sign. And rather than dividing by 4 over m, I'm going to bring it up top and change it to multiplying by its reciprocal. This actually ends up looking then like this. Now I probably am not going to rewrite this every time, but just so you see what we're doing here. In a complex fraction, you take the denominator, bring it up and flip it and change it to multiplication. Then start doing your reducing that you can. And in this case, it looks like my final answer will be an m plus 5 all over 4. Now the second one is much crazier looking. There's different ways to solve this. I usually just kind of break it down into steps. I'm going to start with my numerator because there are two separate terms. I've got this fraction minus this fraction. I like to merge that together into one fraction. And I'm getting a little bit ahead of myself because we haven't talked addition, subtraction yet, but we will. We have to get a common denominator. And so you have to have a 4 and an x squared. That means over here I'm going to take this side times 4 over 4. I'm going to take this side times x squared over x squared. Let's see where that takes us. I'm going to have to take a 4 times this whole quantity, so that's going to turn into 4x plus 20. On the right side here, I'm going to have a negative 1 times this x squared. And that's going to be all over my common denominator, 4x squared. The denominator is still x plus 5 over x squared, which I'm going to bring up here to the top. and change it to multiplying by the reciprocal. And now I'm basically looking at this problem right here. Need to do some reducing, it looks like. I probably have an x squared and an x squared. See how that's being multiplied right there between the 4 and the x squared? That makes either one of those available to cancel. This x squared here could cancel with this x squared here. Then I'm going to look at this numerator and maybe do some rearranging. Perhaps I could do some factoring on that. Plus, I'm kind of picky. I don't like my x squared to be negative. Let's see what I can do with this. I'm going to do a couple things here all at once. I'm going to factor out a -1, and I'm going to rearrange it so it's in decreasing order. Pull out a -1, then it's going to be a positive x squared. It'll be a -4x and a -20. And then that's something I can kind of factor, and I'm just going to leave that -1 out in front. So this has now been replaced with that quantity. And then I hate doing this. I don't want to show you bad, but I'm kind of running out of room, so I'm going to go upward here. And I'm going to write factors of x squared or x and x. And this is where I'm just hoping for the best. It may not factor. A lot of times with complex fractions, it doesn't factor. I'm looking for factors of 20 that are going to give me a difference of 4. And I was really hoping with that 20 that this 5 was going to work out. But if I put a 5 and a 4 here, that's not going to get me this middle term. And if I try 2 and 10, it's not going to work. And if I try 20 and 1, it's not going to work. I think I'm out of luck. I crossed that off, but I'm not sure that that's really going to help me. I think I'm going to have to go back and say that does not factor. And if you want to redistribute that negative in through there, you could. I think I might, just to try to avoid parentheses. Here's my final answer. -x squared, positive 4x, and a plus 20. And that's all going to be over the 4 is still sitting there out in front here. That 4 is still there. And then I have the x plus 5. And I can distribute that if you want. It just, not real picky on how your final answer looks as long as you have all of the different parts involved there. Complex fractions. It's one of those things that kids tend to have trouble with, but it's, you just have to remember you got to do this business where you bring it up and multiply by the reciprocal, and then it's just like a division problem. Let's do some solving. With solving, notice here that you're going to have to do some addition. There's a plus sign here, which means we're going to have to do common denominator stuff. It's an equation, so you have this other side, and you're going to have to get a common denominator all the way through. Looking at your different denominators, you have this 3, you have a 3b, and you have a 6. And you're looking for a common denominator with all 3 of those. Start with your number. You got a 3 and a 6. Your common denominator is going to be 6. As far as your variable parts, this one has a b, so that means these both have to have a b as well. Your common denominator looks like it's going to be 6b. If I want this first fraction to end up being 6b, I'm going to have to take this times 2b, but do it on the top as well. The second fraction has a 3b, so I need to take it times a 2, so it'll turn into 6b. This whole quantity times 2. And the last fraction, if I want it to be a 6b, means I've got to take it times b. I typically go ahead with this addition and turn this all into one big fraction with my common denominator. That's going to end up being a 6b for a common denominator. And in the top, I'll have a 2b squared plus, I'm going to go ahead and distribute my 2b minus 10. That equals b over 6b. Once you get to this point where you have both sides of your equation with the common denominator, basically what we do is say, well, let's get rid of that fraction. Let's multiply by 6b. And if I come over here and I multiply by 6b, it'll get rid of that denominator as well. As soon as you get that common denominator, you're able to get rid of the fractions and you're left with just, well, I say just, it's a mess of stuff, but at least it's not fractions anymore. The fractions are gone. This looks like it's a quadratic, so let's bring the b over here and try to do some factoring. You want it to equal 0 since it's a quadratic. 2b and 1b and factors of 10. My signs are going to be different. I'm going to go with a 2 and a 5. That gets me outer of a 4b, inner is a 5b. That's going to be perfect. Let's make that a plus and that a minus. And now you set those each equal to 0. That's going to end up being negative 5/2. And when I set b minus 2 equal to 0, I'm going to get b equals 2. I have two solutions here. Now before we get crazy and just move on to the next problem, one of the things you have to look out for, and this goes back to the original problem that we had, where we had to find the domain. As soon as you start solving, and the solving is going to happen if there's an equal sign in your equation. If you have an equal sign, that means look out, you don't want to have a 0 in any of your denominators. Now this is a 3, it doesn't even have a variable. This is a 6, it doesn't have a variable. So there's no worries there, but this 3b is a concern. What value of b would make this denominator end up being 0? Well, that's kind of an easy one. You basically you want to make sure that b does not equal 0. That's what you could plug in to make that denominator 0. We really, futuristically, will do that first. We'll do that solving, or I'm sorry, that determining the domain at the very beginning so we don't forget, because once we get clear over here to the end, we're excited to be done and we just keep moving on and we forget to check back in the original problem. You want to make sure you don't end up with something that conflicts. B can't be 0. I didn't get b to be 0. I'm happy. I'm good. But sometimes one of those might conflict and you'll have to X it out and say it can't be that. If they both X out, you might end up with a no solution. Something to remember on the equation problems. All right, so here's an equation problem. Let's try it on this one. First thing you're going to want to do is factor your denominators. And we have some similar denominators here. That makes life a little bit easier. These two are the same. And then as you look at each part of that denominator, I have this n, so I'd want to make sure n doesn't equal 0. And I have an n plus 4. I'd want to make sure that n is not a negative 4 because that would create a 0. Let's write that up here so we don't forget. N can't be 0 and it can't be negative 4. Once we've determined that, we use that denominator that we've come up with and we find a common denominator. Again, we're in luck because these are identical and this is pretty darn similar. We're just missing the n. Let's just take this quantity times n. Same thing up here, times n. And then all three terms will have that common denominator. My next step, I'm going to write my n and n plus 4 here. Equals, I'm going to combine these two together into one big fraction with that common denominator. I'm going to have a 6, and be careful, anytime you have a minus sign, that has to go to everything. So it's like to be honest, I usually like to go plus a negative so I don't forget about that minus sign. Ends up being a minus 1n or minus n. At that stage then, you multiply both sides by your common denominator to make it cancel out. I have 1 equals 6 minus n. Don't know what that is. Let me scribble that out. Add the n to the other side. Subtract the 1. n equals 5. This was not a quadratic, so I didn't have to do a whole bunch of work on solving. I want to go back and check my domain. Doesn't seem to be a problem. Let's box it in and call it good. Last problem, another solving, because these have the most steps involved, so I wanted to do a few of these. Looking at factoring your denominators to start with. Pull out a b. This 2b is just going to stay put. This one I'm going to pull out the 2b, and then I'm going to have a b plus 5. Everything that is getting multiplied has to be part of your final denominator. Oh, let me backtrack. Before I worry about what that common denominator is, let's do our domain real fast. Let's look at all the things that would make your denominators be 0. So this one has a b, so I don't want it to be 0. I don't want it to be -5. This would be a 0 again. 0 and -5. Looks like x, or in this case b, cannot be 0 or -5. Now let's work on that common denominator. I need to have a b. I need to have a b plus 5. And remember, it's everything that's being multiplied. I'm going to kind of separate these two parts. I've got to have a 2 and I've got to have a b. And those are separate ideas there. This b could be the same as that b. And then over here I've got that 2, got it, b, got it, and the b plus 5 we talked about right there. Looks like we need to have a 2, we need to have a b, and we need to have a b plus 5. That's going to be our common denominator. Looking at this first fraction, the only thing I'm missing is the 2. Let's take it times 2, but do that on the top as well. The second one, I'm missing the b plus 5. Multiply, ooh, look at that. I already have a quantity there. I'm going to end up doing some FOIL on that one. And be careful with this minus sign. I'm going to change it to plus a negative. And looking at that, well, actually, I'm in luck. That one already has the common denominator. Let's merge that whole mess together into one big fraction. I'm going to have to do FOIL here, and then it's going to be a -1. The FOIL is going to be a b squared. Outer is a 5b. Inner is 1b. Last is a plus 5. And then I have the -1. On the left side, I don't know why I did the right side first, just because I wanted to, I guess. We need to distribute that too. If you look at this, our denominators are the same. Let's multiply both sides by that denominator. And then it'll cancel out. This side as well. It cancels out, and I'm left with 4b plus 12 equals b squared plus 6b plus 4. This one looks like it's a quadratic because of the b squared. Let's get everything on one side and set it equal to 0. I'll end up with a b squared. If I subtract the 4b, it'll end up a plus 2b. If I subtract the 12, it'll be a -8, and it will then equal 0. Let's factor that. Factors of 8 are going to be 4 and 2. I want a plus 4 minus 2. Looks like I'm going to end up with a b equals 2 and -4. Go back, check at the original, or with the domain. Does not conflict. I'm happy. Let's go with it. All right, we did several equation ones. Hopefully you get the hang of that. That's really where we do all the other stuff. The addition, the subtraction, the multiplication is caught up in the solving. If you can do the solving, then the other part should be easy. All right, good luck.